Good morning, everyone. Hope all is well.
Morning.
Good
Morning.
morning, good morning. How's it going, sir? Good morning. All right. Look like everybody is in. So, like I said, good morning. Hope everybody's doing great. Everybody had a great weekend. And for those who are local, everybody made it through the snow all right. All right. So, we are getting into, hold on with my notes. If I'm not mistaken, yeah, we did. Simplifying expressions. So we should be getting to chapter 3 today.
Chapter 3. Okay.
Mm-hmm.
115. Okay.
Hold on, where are my? So that's fine. Okay, so we did 3-1 last class, combined like terms. Okay. Trying to see why I don't have the. Okay, there we go. MD60 41. Sorry, I got my stuff in the way. All right, so we're looking at 3-2 solving equations. Let me see the official title for you guys on this chapter. $130. Okay. All right, so 3-2 is the addition and multiplication property. So just basically both of these titles combined. So we'll get into solving equations. All right. So an equation is a statement that two algebraic expressions are equal. An example of that is just x plus 5 equal to 7. So we're going to be looking for solutions when it comes to our equations. And a solution is a value or values that will make an equation true. All right. So Whenever you're trying to solve an equation, you want to know when is that statement true. In other words, when is x plus 5 equal to 7? And the answer is when x is equal to 2. And so that's our solution. And you can always check your solution by plugging it back into your original equation. If I would take this 2, plug it back in right here, 2 plus 5 is equal to 7. So it's supposed to create that true statement. So you can always check your solutions to see if it actually works out or not, if it actually is the solution. Is that a question? I see somebody unmuted. Very good. Can I scroll up?
Yes.
All right. So now we're going to be solving. We're not going to just be guessing at what the solutions are. We're going to have a method of solving. So we will be able to solve by what we call opposite, or what I call opposite operations. So these will be operations that undo what the other one does. So addition and subtraction, opposite operations, multiplication and division are opposite operations. So just operations that undo each other. All right. So your equation is going to be split up into right and left side. So in other words, when I look at this x plus 5 equal to 7, there's the right side of my equal sign and the left side of my equal sign. So my equation will be split up according to my equal sign. All right. And my goal is to get x by itself. I have x plus 5, and my goal is to get x by itself. So I need to undo the addition of 5. So if I'm going to undo the addition of 5, I need to subtract 5. But whatever I do to the left side of my equal sign, I need to do to the right side of my equal sign as well in order to keep my equivalency. So the 5 and the negative 5 will cancel on the left, leaving me with just x. And then 7 minus 5 is 2. And that's on the right. And that is the foundation of solving equations. Your goal is to get your variable by itself on one side of your equation. And you do that by performing the opposite operations to undo what's being done to your variable. All right, so before we do a few more, yes.
Could you refresh my memory? A variable is the letter.
Yes.
Okay.
Mm-hmm.
Which is simplifies a number.
It represents a number, right?
Represents the number. Okay.
Mm-hmm. And in this case, it represents 2. You know, when you solve, you actually find out what that variable represents.
Okay.
Yeah. And basically, that's what solving is. You're trying to figure out what number represents that letter, or what number is represented by that letter. Yeah, what number is represented by that letter. Mm-hmm. All right, so let's do a few. All right, so we have y minus 10 equal to 15. In order to solve for y, we need to add 10 to both sides.
Why did you have to add 10?
Because we had a minus 10 at first.
Okay, you got a -10, so you
Yeah.
add a 10.
Because we're
Okay.
using this thought process right here.
You add and subtract.
Yeah, they undo
Yeah.
each other. Mhm.
Okay, so it's a +10,
Mhm.
yeah, +10,
So
okay?
the negative and the positive will cancel, leave you with just y on the left side. And then on the right side of it, equal sign 10 plus 15 gives you 25.
Okay,
All right. So now here, 5a equal to 13. 5a represents multiplication. So that's why I just wanted to remind you of that. If anything's right up against something else, that's multiplication. If I have xy, that's x times y. If I have xyz, that's x times y times z. So numbers and letters right up against each other like that represents multiplication. So to undo multiplication, I need to divide. So
numbers
divide.
against letters,
Mhm,
okay, represents multiplication, okay?
mhm.
Okay,
So the fives cancel. 5 over 5 is just 1. So that cancels, and that leaves us with just 13 over 5.
oh, okay.
Now, notice we didn't turn 13 over 5 into a decimal or a mixed number. You do not have to do it. You do, or you are expected to reduce, but that's not reducing. So here's an example of what I mean by reducing. They will never ask you that. They expect you to do it. So in other words, if you have 4 over 6, 4 is 2 times 2, 6 is 2 times 3. Twos can cancel out and leave you with just 2 over 3. And that's the most simplified fraction that represents 4 over 6. So that you are expected to do. You are expected to reduce your fraction. Once again, that's this process right here. But you do not have to convert it to a decimal or a mixed number. And so since this 13 over 5, we couldn't reduce it. We could leave it as 13 over 5. All right. So questions on that before we look at this last one step.
Oh, okay, that's the one I was good at. Okay.
Yeah, we're about to get to that one. I just wanted to make sure this fractional piece right here is okay.
That's a 6 upside down or a 9?
Right here or right here? Where you at?
Yeah, right there.
Right here?
Yeah,
Yeah, it's my 9.
okay. I'm just asking.
I had one person told me it looked like a shrimp before, so
It sure do. I thought it was a letter.
all right, so looking at this last one step before we go to adding a few more steps to it, we have x divided by 9 equal to 11. So since this is division, once again, we lean on the using your opposite operation. Multiplication cancels out division. So I'll multiply both sides by 9. 9 cancels, leave me with just x. And then 11 times 9 is 99.
Okay.
All right, Professor, let me make sure I got the understanding of this. When you say with the negative, with the addition and the subtracting, and then the multiplication and dividing, you're saying that when in order to solve, when you're doing add and subtracting, if it's if what I'm trying to say, you have to
Okay.
use the opposite when adding and subtracting. And then when added subtract, it's an opposite in order to break it down. In other words, if it's a -5, I have to put +5 in order to get my variable by itself. But when I'm doing division and multiplication, there is a switch around where if it's dividing, I have to multiply in order to get my answer. But if if it's dividing, I have to, if it's multiplying, I have to divide to get my answer.
Yep.
Okay, you know, I could never get that concept. I think I got it.
Okay, cool. Yep.
That concept always confused me.
Trust me, it's all good. I get it. So just to reiterate, for anybody else who may have the question. So initially you'll have a problem like this. What you have initially will dictate how you move forward. If you have addition, and like she just mentioned, if you have addition initially, then you're going to need to use subtraction in order to move that number off of your variable. But if you have subtraction, then you have to use addition to move it off the variable. And the same thing goes with multiplication and division. If you have multiplication, use division. If you have division, then you have to use multiplication. Those will offset what's being applied to your variable. All right. This is a good one right here. Just dealing with fractions. So we have x plus 1/3 equal to 3/4. So we have x plus 1/3. So that means I need to subtract 1/3 from both sides of the equation. And don't forget, the sides of your equation are set up by your equal sign. So we're talking about opposite sides of your equal sign. All right. So the only thing that adds a little extra step here is the fact that we're dealing with fractions. So that means you have to have your common denominator. You can't just add 3/4 and 1/3 together. And it should be a minus sign. Then put that minus sign right here. Yep. So you need to subtract them from each other. But we need a common denominator. Least common denominator is 12. So you ask yourself, what times 4 will give me 12? And that's 3. And so that's why we multiply both top and bottom by 3 here. And that gives me 9/12. Here, multiplying both top and bottom by 4 to give me minus 4/12. And then so 9/12 minus 4/12 give you 5/12. Yes.
Huh?
Say what now?
How do you get that 5/12?
We subtract 9 and the 4 up top.
Okay, I don't jump down. I went straight down. Okay.
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 Oh, so up here, we're gonna subtract, and that's how it come over here. I thought we would see it just going like 2 to 6. I'm sorry. Yeah, I thought, okay. Wait a minute, so then
Sorry.
9/12, okay. Negative, okay, so then 4/4, that would have been.
Yeah, it get me confused. I thought I had this down pat. Wait a minute.
Well, now the process, it may not be the process, it may be the fractions. You know what I mean? Because this is the same process, but now we got fractions involved. So they don't have that many fractions, but this one was in there, so I threw it in there to talk about. Now, if you need to reassure, I had my wrist on. If you need to reassure your fraction process, then that's a different conversation. You know, you talk about adding, subtracting fractions, then you know, finding your common denominator and stuff like that. So.
Okay, so you want, yeah, we went.
I remember them negative signs.
Oh
Me
yeah,
too.
they'll get you.
They'll get you. Okay.
Any more questions on this one before we go to the next one? So, you know, like I said, try this fraction stuff out if you see them. I just know it was one that I saw looking at my notes, so I put it in there. But, you know, if those fractions pop up and you have questions on them, make sure you get them out there. So let me erase some stuff before y'all start copying this.
Oh, we don't need this.
Oh no, I was just saying I was going to erase some of the walkthrough so we can walk through together.
Okay.
Yeah. So. All right. So this is the original problem right here, 2x plus 1 equal to 5. two different problems over here. So we're just looking at the left side right now.
Okay, okay.
Mhm. So we over here. So now we have 2x plus 1 equal to 5. Your goal, as always, is to get x by itself on one side of the equation. So notice we have 2 times x plus 5. So we have 2 being multiplied to x. I said plus 5 plus 1. So we have the 2 being multiplied to the x and 1 is being added to it. All right. So we need to get both the 2 and the 1 to the other side of your equation using your opposite operations. Now, if you wanted, you could divide both sides by 2, but it wouldn't be the most efficient way because notice you're creating fractions for yourself and you don't have to. So the best move is to take care of the 1 first. And since we have a plus 1, that means we need to subtract 1 from both sides. All right. So subtracting 1 from both sides. I'm trying to play around with these colors a little bit. That cancels out on the left, and then on the right, 5 minus 1 is 4. So now we have this statement, 2x equal to 4. Well, that's 2 times x. So that means we would divide both sides by 2. 2's cancel, leave me with just x. And then 4 divided by 2 is 2.
Two x plus 1 equal 5. Okay, 2x. So you pick the 1 and it had been 1, 1. So you subtract it. So now it's 2, 4. Okay.
All right, any problems before we look at the next one? And remember, you can always go back and check this by plugging it in right here. 2 times 2 is 4, plus 1 is 5. So it gives us our true statement. So let's try it again over here. Same setup, just different numbers. We have 6p minus 1 equal to 17. So this time we want to move the 1 over first, but it's a minus 1. So we need to add 1 to both sides. 1's cancel. Leave me with 6p equal to 18. Divide by 6. And p is equal to 3. All right. Any problems with those two before we look at another one? All right, can I scroll up some?
Yes, thank you. Good Lord.
It's not that bad once you combine your like terms. So we have 6x minus 5x plus 4 equal to 19 minus 9.
So
that
6x minus 5x. So you subtracted the 1. So therefore the 1 over here, so it would have been a 4 there. And then you nothing, forget it.
okay. All right. So I think she was on the right track, but she told me to forget it. So you want to look at this and simplify as much as you can on both sides of the equation before you start to move things across the equal sign. So we have 6x minus 5x. It's just 1x.
Okay,
So 1x and x are the same thing. You know, normally you don't write that 1 in front of x. So 1x and x are the same thing. So that's what I have here. And that
Okay.
plus 4, you just bring it down. So on the left side, we have x plus 4. And then 19 minus 9 is 10.
wait a minute, okay, I think I got it right, 6x. So then, did you go back and you said, it looked like you were saying 6 plus 4 is 10, and 5 plus 9 is 9, so it came out to be 19, and then you subtracted it?
Oh, no, I think you're going too deep. All right, so
Oh.
6x minus 5x is just this 1x right here.
Okay,
And
1,
then plus 4 just comes down right here.
okay,
So that's x plus 4. That's the left side of the equation. Then 19 minus 9 is 10. And that's all we done up
how
to
did you get the 19?
that was given. No, that was the original problem.
Oh,
Yeah, that was the original problem. Yeah.
okay,
Yep.
I done made up my whole new problem, okay.
All right, so now once you simplify both sides as much as possible, now you can solve for your variable by subtracting 4 from both sides. And so 4 cancels on the left, leaves you with x. 10 minus 4 on the right is just 6. All right. Are we good with that one before we go to another one? So I'm just
Okay.
going to show you just different scenarios of solving equations.
Okay,
All right, so let me erase this. So here, 5x plus 33 equal to 4x minus 16. So notice we have x in more than one term. And your goal should be to get, excuse me, your goal should be to get all terms with x on one side of your equation. And it doesn't matter which term I decide to move first. Notice we have 4 different terms. I have 5x, 33, 4x, and 16. So it doesn't matter which one I decide to move to the left or right first or whatever. As long as you do everything correctly mathematically, you'll still get the same result. So I want to get all of my terms with x to one side of the equation. So what I'm going to do is minus 4x. Notice I'm not separating the 4 from the x. I'm moving the whole 4x to one side. So 4x minus 4x will cancel on the right. And then 5x minus 4x is 1x on the left, leaving you with 33. I mean, x plus 33. On the right, we just have a -6. And make sure you don't lose your negatives or minus signs. That was a minus 16, so that 16 needs to stay negative. All right, to finish it off, subtract 33 from both sides so I can finally get x by itself. 33 minus 33 cancels. Then on the right, -16 and -33 is -49.
I'm sorry, I'm confused again.
What you got? No problem.
Okay, and the one up there, you added that one. But I mean, you subtracted, but down here, you added it.
All right, you talking about adding this?
Yes.
Or yeah, because they both have the same sign. So that goes back to our sign.
Oh, okay, I get it.
Yeah. Okay, you good? Okay.
Yeah.
And so just for the room, because we have the same signs here, it means we add them. If we had different signs, let's say if that was a positive 16, then we would have been subtracting those numbers. Yep. All right, don't copy that one yet. I think
Okay.
this goes into the next section. Let me make sure. Add, subtracting, I think. Let's be multiply. 2, 4. I'm missing this section. Solving linear equations, 33. Introducing problem solving. Okay. So this should be, okay, we did a problem like that. We did one similar to this. Trying not to double up on y'all.
Well, you did this one?
It was similar. I'm gonna come back to it though. I don't want to do that one yet. Yeah, let's do this one. All right, so this one right here. So you may have problems that deal with fractions, but we can clear them out. Do what we call clear out the fractions. Here we have 4 over 5 equal to 1 over 5 plus 3 over 4x. And like I said, we want to do what we call clear out the fractions. So first thing you want to do is find the LCD. So you look at all of your denominators. We have 5 and 4. And ask ourselves, what's the LCD of 5 and 4? And that the LCD is the smallest number that each denominator can divide into evenly. So it's not about what can divide into them, it's about what they can divide into. So if we look at 5 and 4, the smallest number that both 5 and 4 can divide into evenly is going to be 20. So same thing happened when we had 3 and 4. The smallest number that they could divide into was 12. That's where I got that 12 from.
Okay.
So the smallest number that 5 and 4 can divide into will be 20.
Right. Okay.
So now let me erase this. We're going to multiply each numerator by the LCD. Notice we didn't multiply top and bottom by the LCD. We just multiply each numerator by the LCD, just top number by that 20. All right, are we good to go to the next step? All right, so now 5 divides into 20 and leaves us with 4. So we in step 3, talking about reducing. 5 divides into 20 leaves us with 4. 4 divides into 20 leaves us with 5. So now we have this 4 times 4 equal to 4 times 1 plus 5 times 3x. All right. So now if we were to simplify that, 4 times 4 is 16, 4 times 1 is 4, 5 times 3x is 15x. And so now we can solve this equation and we don't have any fractions involved. All right, any questions before we go ahead and solve this? Mhm. All right, so we have 16 equal to 4 plus 15x. So notice the first thing that you would do is subtract 4 from both sides. So that would be 12 equal to 15x. Then to get a 15 off of x, divide both sides by 5. I said 5, 15, excuse me. Divide both sides by 15. And that'll be 12 over 15.
Four over 5. Okay.
And then right, that 12 is 3 times 4, 15 is 3 times 5. Those threes can cancel and that will reduce to 4 over 5.
Now I do got a question.
Mm-hmm.
How? Oh no, I see it.
Okay, sounds good.
I see it. I'm okay. I see it. I know you get sick of me.
Oh, no, you're fine. I have no problems at all. All right, everybody done with this problem? See this
Yes.
next one. That was the same thing. That was me doing something different. So let me do this. All right, so let's go back to our page 130. Okay, and this is 3, 3, 3, 2, and 3, 3. All right, so let's look at this problem right here. So 3, 2, and 3, 3, I normally just do together. So really, if you were to go back to your notes, you can do 3, 3, and 3, 2. All of it is solving linear equations. 3, 2 introduces it. 3, 3 just add more steps to it. So we're really doing 3, 2, and 3, 3 together. So like I said, you can go back to the title of your notes and put 3, 3 with that 3, 2. 3, 3 is just solving linear equations. So ignoring the purple and green boxes. So we have 2x plus 3x minus 5 plus 7 equal to 10x plus 3 minus 6x minus 4. All right. So just like I mentioned before, whenever you have a lot of terms going on, the best practice is to simplify as much as you can on one side of the equation, simplify as much as you can on the other side before you start to move terms across your equal sign. So when you look at that left side of your equation, we have 2x and 3x. That'll be 5x. Then you have minus 5 and a positive 7, which would be positive 2. So that's how we get 5x plus 2 over here. And then over here on this right side, 10x minus 6x is 4x. And then 3 minus 4 is negative 1. So that's how we get 4 minus 1 on the right side.
10x minus
6.
Where did 6 at?
Right here.
Oh, I can't see it. I'm sorry.
So, is that in a way one of your boxes again? Is that,
Yep. Okay.
let me see if I scroll it up that better.
Yes. Okay.
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 All right. So I've already said this before, but just wrote it out this time. So your goal, whenever you have more than one X term or more than one variable, and you're trying to solve for that variable, your goal should be to get all of your terms with that variable on one side of the equation, all of your terms without that variable to the other side. So notice we have 5x plus 2 equal to 4x minus 1. So I need to get the 5x and the 4x on one side of the equation, the 2 and the negative 1 to the other side. So I did that down here, starting that off. I scroll up. Everybody okay with me scrolling up? So I subtracted 4x from both sides. That cancels right here. And then over here, 5x minus 4x, and that'll just be 1x. So now we have x plus 2 equal to negative 1. And then we can subtract 2 from both sides. And that'll be x equal to negative 3. All right, any questions? Any questions? All right, can I scroll up?
Okay.
Okay, so here's some decimals going on. Let me see, do I want to erase this? Yeah, go ahead and erase this. All right, so you can handle this type of problem one of two ways. Whenever you have decimals, if you want to clear out your decimals, just like we cleared out fractions, we can multiply across the equation. In this case, since we're in the 10th place, we have 0.1 and 0.6. We can multiply everything by 10. Just remember that whatever you multiply to 1, you have to multiply to all in order to keep your equivalency. So to get rid of the decimal, I multiply everything by 10. You do not have to do this. You could just work with the decimals and just use your calculator and you'll be good. But I think Math Lab asked you about this process, so that's why I'm making sure that you're okay with what happens here. So 10 times 0.1 is just 1. That's just 1x. 10 times 0.6 is 6. 10 times 6 is 60. And then 10 times 19 is 190. So you multiply it by 10 in order to clear out the fact that you have decimals in your problem. So before we go any further than this part, any questions on how we got there?
Yeah, Professor. So if I can remember that's
Hold on, you broke up. You broke up right when you're trying to ask your question.
intermediate class that I took, whatever the name of it was, to prepare me for this class. Thank God I did. So the reason why we're doing 10 is because of where the decimal is, right?
Mm-hmm.
Meaning, if it was right, it would have been the hundredths place.
You got it. Mm-hmm.
Okay.
Yep.
I just remember a little bit of that from
Yep.
last.
Yep. So good statement, good interjection. So what she's saying is that the decimal place, 10th place, we multiply by tens. Now, if one of them, even if just one of them had a second place, that would be the hundredths place, then we have to multiply by 100. If you saw, and remember, whatever you do to one, you have to do to all. So it's just this, you can't multiply this one by 10 and multiply this one by 100. No, whatever you're going to multiply by, you have to multiply all of them by. If it was 0.752, now we're in the thousandths place. So now I need to multiply each term by 1,000. So however many decimal places you see, that lets you know how many zeros you need behind that one. And that's what you have to multiply each term by. Once again, you don't have to do this if you don't want. You can just work it out with the decimals. Same thing with the fractions. If you don't want to clear out your fractions, you just want to work with fractions, feel free. Just that these methods allow you to clear out decimals, clear out fractions, and give you possibly an easier way to get to your answer. All right. So once you get past that, x minus 6x is going to give us negative 5x. And that'll put us here at negative 5x minus 60 equal to 190. So now we'll add 60 to both sides. 60s cancel. Leave me with negative 5x equal to 250. Then to get negative 5 off of x, x will be equal to, we divide both sides by negative 5, and x will be equal to negative 50. All right. Questions before we do another one?
Yeah, I just didn't know where the 5 came from.
Oh, okay, because don't forget you have a 1 sitting in front of this x. So we have these two like terms.
Oh, okay, I get it. Okay.
All right.
Okay. It's an age thing.
Oh, no, you all right. You're all right. All right, can we scroll up? Everybody good? All right. So let's do another clearing out the fractions. Can't hurt to walk through it again. Here we have x over 2 minus 1 equal to 2 over 3x minus 3. And the first thing we want to do is find the LCD like we did before.
Professor,
Two-
can I ask you a question?
Yep.
How do we know exactly when that X is in the middle like that?
I did that purposely to let you know it's the same thing. I could have wrote this as 1 over 2x, but these are attached. So it's the same thing as x over 2 because there's a 1 sitting in front.
Actually referring to the 2 over 3, and
Mhm.
you said it's 2 over 3x. So,
Mhm.
but you got 2x over 3.
It's the same thing. That's what I'm saying. Like all that's the same. That's the same thing.
Okay,
So
so the
2x.
X represents to 2 and the 3?
Yeah, it goes to, yeah, that 2 over 3 is one whole number.
Right, so is
Yeah.
that 2x over 3x for real?
So it's 2x over 3 or 2/3 x. Either way, it's the same thing. Now the x will never go into your denominator and be the same thing. It's just sitting on the side of it. It's either
So
up top or
it always goes to the numerator. If it's
yes.
an X on the side, it goes to the numerator.
Yes.
That's what I need to know.
Uh-huh.
Okay.
Yep. You put it in the denominator, it's a whole different problem. Yeah.
Okay.
Mhm.
Gotcha.
All right. So LCD is 6 because we have 2 and 3 in our denominator. Smallest number that both 2 and 3 can divide into evenly would be 6.
Mhm.
So we're going to take that 6 and multiply it to each numerator, just like we did last time.
Mm. Okay.
All right.
Wait a minute.
Yep.
Okay.
Yep.
Oh, I'm gonna do minus. That minus sign is gonna be minus. Why wouldn't the minus go inside the parentheses with the 1?
It doesn't matter. You could, if you put it in there, but you can't forget to not do nothing though. So you have to put a plus here. I think you'll be making it more stuff going on than it has to. So that's why I just did it that way. Just let your signs be.
So it can be done either way.
Yep. You just have to be careful that you don't do nothing and then somewhere you don't want to start losing stuff. You know what I mean?
Right. No, I got you. Okay.
All right. Everybody good before we go to the third step?
Wait a minute. Let me write that down. Wait a minute.
Okay.
Minus.
That's a 3 minus 6
Times
in the
3.
parentheses. In the
Yep.
parentheses, that's a 3.
Yes.
Okay.
Uh-huh. Yep.
The thing keep going over it.
Oh, yeah. I forgot about your thing.
Okay. Thank you, sir.
All right. Not a problem. That good enough? That's okay. So now step 3, we're going to simplify. 2 goes into 6 and leaves you with 3. 3 goes into 6 and leaves you with 2. So that's both of these spots right here.
Mhm.
And then when you simplify that, that would be 3x minus 6 and 4x minus 18.
Wait a minute. Okay. So what you did was 2, and then you did the 2 times the 2x. Okay.
Mm-hmm.
And I got that. Okay. 3 going to 6 2 times. And then it's times that 2. And a little arrow there. Which makes that 2x. Damn. Wait a minute, I got lost for a second. Hold up. That's gonna make that 4x. Okay.
So
Okay, I got
you
you.
mark that out. So it would have been 3 over 1. So that's, you brought down that one, that's 6. So then you mark that, we put into that 2 times 2 is 4. And over here, the 18. Okay. You making it simpler, but I'm just slow.
Oh, you all right? Ain't nothing wrong with you.
We the old school students.
That's right. We over 6. I'm over 6, almost 65.
Oh no, boy, that old.
Well, I'm on grade turn 64, so I'm sorry.
Well, good job. I commend you for going to school, back to school.
Okay, thank you too. You good,
Most
commend
definitely.
you.
Most definitely. All right. So are we good right here? Everybody good before we start solving? All right. So now, say again.
I said, we ain't solved it yet.
Oh, no, not yet. So we have 3x minus 6 equal to 4x minus 18. Now, once again, your goal is to get all of your terms with x to one side, all of your terms without x to the other. Once again, it does not matter which one you decide to move first. and which side you decide to go. You just have to be consistent in what you do mathematically, and you'll be all right. So I decided to subtract 4x from both sides. So 4x minus 4x cancels on the right. 3x minus 4x is negative 1x. And I did that purposely just because a scenario is going to be created, and I want to make sure we're clear on it.
Wow.
But if you wanted to, you could have took the 3x over.
Yeah, that's what I was doing. Can I go ahead and do it that
Yeah.
way?
Yeah, you'll still
Okay.
get the same answer.
Okay.
So now we have negative x minus 6 equal to negative 18. So now I need to move my 6 over. Ms. Glover, you would be taking the 18 over. You know, if you
Okay.
took the 3x over there, you take the 18 to the left.
Wait a minute. See, I should be stayed with class.
It's okay. So now what you would have did, no, it's
Go
okay.
ahead, go ahead. No, y'all go ahead. I just ain't took time to work it out yet. Let me work it out yet.
I would have.
So I'm gonna still end up with X on both.
No, so what
No,
you
no,
would
no,
have
no.
done,
No, I'm not. Okay, okay,
if,
okay.
yeah,
I
if
got
you
it.
had subtract 3x,
Okay.
3x would have canceled, you had negative 6 equal to x minus 18. And now you got to take the 18 over by adding 18 to both sides.
Okay.
All right. So for those who are with me, we are here. We
Right.
have negative x equal to negative 12. So what I want to do is create a scenario that it is possible you could have negative sitting in front of x, or in front of your variable. Don't forget, you're not solving for your negative variable. You want your variable to be positive. So you need to take this negative over to the other side. And
Okay.
Oh, I don't know something.
And then so negative to a negative turns positive. So your result is positive 12. X is 12. So Ms. Glover, you said you were right here, right?
Mm-hmm.
And did you add 18 to both sides?
Mm-hmm. It didn't seem like.
Then it should be 12 equal to
Oh,
X.
that's why I went wrong. That's why I went wrong. I added. My bad. I was
Okay.
like, why I got negative 24.
Okay, she added, okay.
No, I did. So did I add 24.
Mhm. All right.
That's where I made my mistake at. I was supposed to add because I didn't bring down my negative in front of my 18. So I had to add 18, which make that be X, and this will be 18 minus 6 is 12.
Mhm.
So if you're right, we got the same 12 equals X.
Mhm.
Yeah.
Yeah.
Now see, I didn't have to do this negative and positive stuff like y'all did over there for that negative 12 to make it equal 12.
Right. That's because you went the other way.
Okay.
Right. Yeah. Mm-hmm.
Gotcha.
All right. Everybody good with this one before we, let me see how much time, what time is class in?
1:45, ain't it?
Your guess is good as mine. I believe you.
1:45.
I think this the last, yeah, let's do these last two and then we'll be done. All right. So these last two are going to create scenarios that you're going to have to remember when they come across you, because if not, then you'd be like, well, what in the world is this? All right. So let's look at these. Somebody said something in the chat. Thought it was 2:20. You might be right. I didn't look. Let me see. This class
It's only
was,
an hour and 15 minutes.
we get out of this class at 2:50. Hold up, wrong class.
250, 150.
Yeah, 150.
150.
150.
Oh, 150. I thought it was 145, 150. Okay.
Yeah, 150. All right, so we got plenty of time to get through these two.
Yep, you're doing good.
So first thing we do, so notice that we have negative 2 times x minus 5 plus 10 equal to negative 3 times x plus 2 plus x. So the first thing you want to do is distribute the negative 2 and distribute that negative 3 into those parentheses. And that'll give us negative 2x plus 10, because that plus 10 is still there. And then negative 3x minus 6 plus x. So after your distribution, we are right here. All right. So as always, look for moments to combine your like terms if possible. So here, 10 and 10 gives us 20. And then over here, negative 3x and 1x will give us negative 2x. So now we're here. We have negative 2x plus 20 equal to negative 2x minus 6. Once again, your goal should be to get all of your terms with the variable on one side, all of your terms without the variable to the other side. So what I decided to do was to add 2x to both sides of my equation. So this is where it can be tricky if you're not careful. What a lot of people like to do is they make a mistake and they will add 2x to both sides, let it cancel over here, add 2x over here, and then they'll have x minus 6 because they're scared to let it cancel on both sides. So the way math is set up is that if something happens on the left side and it cancels, if that same thing happened on the right, I mean, you still got to cancel, it don't change because it happens on both sides. So your variables cancel out completely, and that leaves you with 20 equal to negative 6. So it's okay for your variables to cancel out completely. It's just that it's going to create another scenario for us, which is what we're going to talk about in my blue letters down there. But once again, notice what happens. We add 2x to both sides of our equation, and the 2x cancels out on both sides of our equation, leaving us with just numbers. And we have the statement that 20 is equal to negative 6. All right. So this creates the scenario. Notice that our statement here is false because 20 is not equal to negative 6. Now our answer is not false, but we have a false statement. So whenever your variables cancel and we have a false statement, your answer is no solution. Once again, do not write false statement as your answer or write false. The answer is no solution. Only reason I'm saying it because I've seen it done many times. So just be
And
careful.
I would have done it.
So yeah, so I tried to look, I put it in a purple box and I wrote answer beside it. I put 3 asterisks in there. They're trying to help y'all out. So,
No
so
solution.
no solution is the answer. Whenever your variables cancel out completely and you end up with a false statement, the answer is no solution. All right. Can we go to the next one? Am I still? All right. So this one is very similar. So we're going to distribute. We have 3 times the quantity of x minus 4 equal to 3x minus 12. So we distribute the 3. And that leaves us with 3x minus 12 equal to 3x minus 12. And I didn't mention before, but I mentioned it now. You could have gotten a different set of numbers depending on when you added or whatever. Let's see. You could have gotten 14 equal to 0, 26 equal to 0, or negative 26 equal to 0. As long as it says a false statement, your answer will still be no solution, even if you don't get those same exact numbers. It will depend on the order that you do your operations and stuff. Same thing here. We're going to subtract 3x from both sides, and they're going to cancel, leaving me with negative 12 equal to negative 12, which is true. Right? Or I could have had 0 equal to 0, which is true. So it is possible to get different numbers, but the statement will still be the same, either false statement or true statement. So when I go down to solve, I get a true statement here. And when your variables cancel and you get a true statement,
real.
Yep, the answer is all real numbers. So in the one previous to this, that means that there's no number that you can plug in to make that a true statement. There's no solution. In this one, it don't matter what you plug in, it will always work. So that's what it means by all real numbers. Any number you plug in there, any real number you plug in will work.
Professor,
Yes, ma'am.
are you saying that we could have canceled out these negative 12 on both sides too and let it been 0 equals 0? That what you said?
Could you hit that first if you want
Oh,
to?
okay, okay.
So what would you prefer? How would you prefer us to do it? Just leave it that way or go ahead on and cancel it out?
As long as you get all real numbers, I don't care. It's still gonna give you the same thing. So it really becomes a preference
Oh,
thing.
I need to write that down when all variables cancel out. I
Mhm.
need to write that down when all variables cancel out. It's a true statement.
No. When all variables cancel out and you get a true statement. See,
Okay.
remember up here, variables cancel out and we got a false statement. So your variables can cancel and give you a false statement, but it depends on the numbers that you have set up. So here, when
Oh,
my variables cancel, I had 12 equal to 12, or like you said, you could have had 0 equal to 0. That's true. But if your variables cancel out and I have 26 equal to 0, or like I said, I have here 20 equal to -6, that's false. So your
and it's
variables, right? So your variables can cancel, but from that point, it can be true or false. But what dictates that are the numbers that you have on both sides of your equal sign.
Are
and
they the
okay.
same numbers? They 12 and 12. So if it would have said 14 and 12, it's a false statement.
Yes.
Okay, okay.
And Ms. Glover, were you saying something else?
Yes, I want you to slide up just a little bit. Let me see what that last little bit in the block say. No, up. No, the other one.
Are you talking this way? All right, hold on. You went out on me.
The true statement.
Yeah.
I wanted you to
Yeah.
go all the way down. Okay, all real numbers. That's what I wasn't.
Okay.
All the answer is always real numbers. Okay.
All
That's
real
what I
numbers.
needed.
Mhm.
Is always real numbers. So true statement is considered real numbers.
Yeah, if you variables cancel and you get a true statement, your answer is going to be all real numbers.
All real numbers. Okay,
Mhm.
so hey, right. Let that out. Okay, gotcha. You.
So that's it for my examples for 3, 2, and 3, 3. Try the stuff out. See if you have any problems. I remember Miss Braxton had a problem. She shot it to me. We went over in class. Or if it's something that you want to make a quick video on and send it to you because you don't want to wait till class, anything like that. I mean, it's all good. Let me know. Come to office hours, whatever you want to do. Just make sure you have those problems ready so that we can just, knock them out. So like I said, help me help you. If you have a problem with solving equations, don't just come to class and say, I got a problem with solving equations. Bring a problem so we can solve it and walk you through it and stuff like that. That'll be the easiest and the most efficient way to get your questions answered and make best use of everybody's time. So if you ever have a question, yes.
Yeah, I did have one that I had an issue with 2.4, question 33 and 34.
Okay, hold on a second. Let me get to a page and let me say this as well. So she has a problem that she wants me to walk through, and that's not a problem. If you're good and you don't want to sit back for a question, I'm not doing any more new lecture for today. That's it. So feel free to stay back and I'll walk her through her questions. Or if you have some more questions, feel free to sit on. Other than that, you guys have a great day. Be safe, and I will see you on next class.
Hey, Mr. Tucker, how you doing?
Hey, how you doing?
Cause I'm the one who emailed you about my soon as I ordered, my access, it locked me out the computer
Okay.
and my phone. So I'm trying to get back in touch with them and see, what's going on with that. But other than that, I'm gonna probably tell them to cancel their order and try to go to bookstore and get the access code. Cause this
Okay. Now I see your name. I see your name in here now.
Yeah, I started, but then after the trial period was up, it just went crazy on me after I paid for it. It just went blank, like I'm
Now,
locked out.
let me ask you this: how did you try to log on?
I
Like what email address are you using?
TandraHogan@gmail.com.
Okay, so you are using the right email. You said it locked you out and you couldn't.
Yeah, and it keep telling me to change my password. So now the lady said I got 2 emails in there and I got like multiple accounts. I was like, I don't know how that happened.
Right. So, okay, they might have to deal with that and fix that on their end.
Yeah,
Uh,
I started,
mhm.
trying to, do my work, even though I had missed first week of class.
Yeah.
But I'm going through that. When I get off the phone, when I finish with you, I'm gonna go on the phone and see, where they at with that.
Yeah. Let me know what happened because if I need to get the rep on it to move a little faster or something, then I'll do that. But let me know what you find out and
Okay.
and we'll go from there.
Professor, I had to use my school email. She said she used her Gmail.
Yeah, it depends on how you set it up. You could use your
Yeah,
Gmail. Mhm.
yeah.
Okay.
Yeah. And
Mhm.
so, and when you email me, if they don't get it straight, email me the situation so I can forward it to, you know what I'm
I
saying?
did it today. They
Okay.
told me to do the code or whatever, the
Mhm.
case number. I
Mhm.
sent it to you. I
Yeah.
resent.
Yeah,
Okay.
yeah, I did see that today. So if they can't figure it out or you can't get through or whatever, just let me know and I'll forward that and then we'll try to get you straight.
Okay. Thank you so
All right.
much.
No problem. Thank you.
See you Wednesday.
All right, take care. Bye.
I don't know if something going on with Paradigm or not, because I've been trying to log in since we've been online here, and it won't let me log in.
It won't let you log in. Hold on,
I
hold on,
wanted to
hold
go
on.
over, let me see. I'm gonna try. It won't let me log in. But my question was, you could probably pull it up, I would think.
Mhm.
It was like I said, in 2, 4, 33, and 34. I got a little confused with it and understand why is one negative and the other is not. So I just wanted to clarify something.
34. Yep, give me a second. I'm getting there.
I don't know why they letting me sign in today. Let me see.
All right, so you're
Okay.
talking about this right here. That's 34. And then 33, this is what you're talking about?
Uh-huh.
These two?
Yes.
Okay. All right.
Now, when they work the problem out, perhaps it's wrong. Like I can't. I'm trying to get up in here.
Mhm. All right. So you ready for me to show you or you want me to hold on?
Man, let me see, can I get in here again? It has not been letting me in. Okay, it opens up, but then when I click on it, no, I see it's trying to be funny, man. Open right up. I'm gonna go to it. I'm gonna go to it as well so I can, and it was I said it was 2, 4,
Mhm.
4,
30
4.
33, 34.
Okay, see, moving slow. Maybe because I'm on Zoom in here. See, it won't open it up for me. Okay, so where I got confused at was, of course, I got them right in here, looks like, but that's because I had to go through the example.
Mm-hmm.
But I didn't understand why they did it the way they did it.
Okay, it's all about these parentheses and not having parentheses. So parentheses means that whatever's inside of parentheses is being included. So when I go here, this is -4 times -4, which would be positive 16. So from that point, it's positive 16 plus 9. Now here, though, that negative is sitting there, but there's no parentheses. So the only thing that's being squared is 4. And so that's -16 still. So this is negative 16 plus 9.
So that's -16, but the negative is still in front of both of them though, or it's only for one.
Oh no, it's not about it being in front of both of them. It's about, and that was a cube too, but it's all good. But it's not about part of being in front of, it's about being inside of the parentheses versus not having parentheses at all. See what I mean?
inside the parentheses, it applies, the power applies to both.
Yes, and then if not, then it only applies to what it's right up against. So if I had x, y squared, then that square needs to be applied to both the x and the y. Now we haven't gotten into this. I'm just giving you an idea as to how it works. So that's
Okay.
x squared and y squared. So it applies to everything that's in the parentheses. But if I have x, y squared with no parentheses, that square is only applied to the y. So that's the same thing that's happening here with this negative. Everything inside this parentheses is being affected by the square. No parentheses mean that the only thing that's being affected by the square is the 4.
But they want you to do the 4 twice. I'm just confused, but I get what you're saying. That's just the rule.
Yeah, they want you to do the 4 twice, but the negative is not being done twice.
Oh,
See,
gotcha.
yeah, the 4 is going to be done twice. You're absolutely correct, but that negative is not being affected because there's no parentheses included.
Okay.
Yeah.
Gotcha. So it only affects D4, but the negatives does still remain there. It's just not affected by the second
Yes,
power.
exactly.
Gotcha.
Exactly.
That was I just couldn't figure out how they one gonna be with negative 16 is the same thing. My mind was telling me. You know,
Right.
so what made I just needed to know what made it different.
Mhm.
Okay, that was it. That was my issue that I had.
Okay, cool. Not a problem. Good question. Good question. All right. Anybody else before we close out? It's 1:50.
Y'all have a good day.
All right. You do the same. All right. Everybody good? All
Yeah, I
right.
can't find the one I wanted. I just wait.
Okay. All right. Not a problem. If you find it, you know where to find me.
All right. Thank you, sir.
All right.
Thank
Have a
you.
good one. Take care.
I have a couple that I had wrote down, but I
Okay.
can email you for like a time that's good for us to go over. I think once like you walk through a couple with me, I'll be able to figure the rest out.
Okay. Now, did you see my office hours? Because those I shot those out to you guys as well. If you can make those, you can just come to the office hours.
Okay, yeah, I'll check that email
Yeah,
again.
check it out. If not, then shoot me the email and then we'll talk about it. No big deal.
All right, thank you.
All right, man. You have a good one.